Good morning, good afternoon, good evening to everybody. As we told, we are going to present you the new approach for assessing the certainty of the evidence that has been proposed by the GRADE working group using the absolute estimate of the fact. And we are organized the presentation. We will alternate, Francesco and I will alternate, and I will present you the methods from a general perspective, and then Francesco will explain more in practical how each step of this approach has been can be implemented. Uses an example, the systematic review on the treatment for Alzheimer's disease that has been of which we are co-author and that has been published just like last week on the Cochrane Library. So the next, please. I don't have any conflict of interest in related to this presentation. This is my disclosure, and the same is true for Francesco. Can you move down? Thank you very much. So the next slide, please. So the GRADE working group decided to revise and update the approach to assess the certainty of evidence in the last period. The whole process lasted about 2 years. And the decision to update the approach is grounded in the realization that when deciding whether evidence of intervention effect is adequate to support a recommendation or also to draw conclusion about efficacy if you are conducting a systematic review, we are not actually assessing our confidence in a point estimate of effect, but rather we assess our confidence in where the effect lie relative to a particular threshold which are relevant for clinical practice. So the crucial point is that this approach is focused on what is relevant for clinical practice more than to what is relevant from a statistical significance of the results. And furthermore, the GRADE working group realized that with the old approach, the user for GRADE were not yet optimally supported in their decision on how many levels downgrade the evidence for each of the individual domain. The next, please. Yes, the full description of the new approach is reported in the GRADE book, which is available online in the link that was shown in the previous slides. So according to the new approach, the certainty of the evidence reflects the confidence that the true value lies within a specific range or below or above a definite clinical threshold of interest, okay, which has to be defined, with the point estimate serving as the best available approximation of the intervention effect. And consequently, therefore, the certainty of the evidence and the rating the certainty is closely linked to the application of these defined clinical decision thresholds or in interpreting the estimating effect. The next, please. This new definition, this new approach made necessary also to revise the definition of certainty of the evidence. And according to the new approach, the definition of high certainties, of each level of certainty, is that we have high certainty when we have high confidence that the true value of the estimate of interest is at one side of a threshold or within a specific range of thresholds. The same for moderate certainty. You have moderate certainty where you are moderately confident that the true value is at one side of a threshold of interest or within a certain range, and the same is for low certainty and very low certainty. So the certainties is defined according to the threshold of clinical relevance that have been defined. The next, please. Okay. So to apply this approach, the first step and the first thing that is important to notice is that the certainty of the evidence should be assessed basing on the absolute estimate of effect. So if you have continuous outcome, you will assess the certainty of the evidence of the effect measured in terms of mean difference or standardized mean difference, which are absolute estimates. While if your outcome is dichotomous, you have to convert your relative risk into an absolute risk difference, an absolute measure, which is the absolute risk difference. And all the evaluation is performed using the absolute risk difference as a measure of effect. The second step is to assess the number of thresholds if you are interested in. And you can choose between an approach more general, less contextualized, to say that could be to choose just two threshold of interest, that in one side in favor of favorable effect, and the other on the side of unfavorable effect. And this is a single threshold, one on one side and the other on the other side, distinguishing between no effect and any effect. Okay. And this threshold is the same, is coincident with the minimally clinically important difference. Otherwise, you can choose the approach to define 6 thresholds, 3 on one side and 3 on the other. And one threshold distinguishes between trivial no effect and small effect, the second one between small effect and moderate effect, and the third one between moderate and large effect, on one side and on the other. The next, please. Okay, this for a plot depicts what I have just said, but in a figure you can see that you have the first plot, and then you have a space space in the middle, which is the trivial no effect, and then there is a clinical threshold, a decision threshold, which distinguishes between trivial and small effect, another between small and moderate, and a third between small, moderate, and large. Each on the side, for example, if we are assessing mortality, the desirable outcome is a decrease of mortality, and so you have 3 thresholds that distinguish that you allow you to say that you have a small, moderate, or large effect, favorable effect in decrease of mortality, or if you have a small, moderate, or large increase of mortality, so undesirable effect. Another point that is very relevant to notice is that the line of no effect, which is reported in this first plot, does not have any more relevance. The next, please. Thank you. Has no relevance anymore for defining the efficacy of the intervention and also the certainty of the evidence. And this, so the line of no effect is that when risk relative is equal to 1, or the mean difference or standardized mean difference is equal to 0, or the absolute risk difference is equal to 0. Because we are not interested in the statistical significance of the results, but in the clinical relevance. And as you know, results can be statistically significant, but still have no important significant or important from a clinical point of view, because it doesn't change anything in the health of the patient. These very small differences that you can find. So the next, please. Okay. Once you have decided, at this point, you have to define the decision threshold. So how to do? If you have continuous outcome and you you use as a measure of effect, you computed the standardized mean difference, the suggestion is to use the Cochrane D thresholds. Which are 0.2, which distinguishes between trivial no effect and small effect, 0.5, which distinguishes between small and moderate effect, and 0.8 between moderate and large effect. This is one approach with 6 thresholds, 1 on this side, 3 on one side, and 3 on the other side. Alternative, if you decided to express your results in terms of a mean difference, for example, when you use a scale or some other value that can be expressed in terms of mean difference of continuum values, you have to identify the minimal clinically important difference. that is, which distinguish between trivial no effect and any effect. And the minimally clinically important difference can found in the literature. You have to look in the literature if you can find that not for all the scales or all the measure, a minimally clinically important difference has been defined, validated, and published. The next, please. For dichotomous outcome, the approach is a little bit more complicated, but still feasible. So the first step is to translate your relative risk into absolute risk reduction and express your results in terms of absolute number of events over 1,000 participants. Then you have to determine the health state utility values for each dichotomous outcome. The health utility values is a summary index measure that express the impact on overall health and well-being resulting from having that outcome on a scale that comes from 0 to 1, where 0 is death and 1 is full health. These utility values need to be established a priori as any other methodological aspect of a systematic review without knowledge of the intervention effect and hopefully at the protocol stage. And just an example, for a moderate diarrhea, you can define a utility value of 0.9 because a moderate diarrhea has a minimal impact on a full health state, while for pulmonary embolism, you can have, or you state an utility value of 0.42 because it has a larger impact on full health state, and even greater, for example, for stroke, you can define utility value of 0.3. Which is more close to death and has a big impact on your health state. How to define this utility value? You can search for the already elaborated utility values for the outcome, looking in the scientific literature and mainly at the studies on the economic evaluation, because the utility values is a concept that has been motivated by the studies that evaluate the cost effectiveness of the intervention. Or you can ask the panel members to express their opinion about their judgment about the utility value if you are conducting and doing a clinical guideline. Or you can ask the authors of the review with clinical content knowledge and to patient representative to propose their utility values. In these latter two cases, then you compute the mean of the median of the values to obtain one final value that will be used. The next, please. Once you have the utility value, this must to be multiplied by a generic coefficient using a formula which is based on a methodological randomized studies on interest holders that have been, whose method and results have been published by Morgano in 2022, where it reported the method that were used to elaborate this formula and the generic coefficients. But there is also a software that has been elaborated and proposed that automatically calculates for you the decision threshold. In the software is accessible at the link that you can see in these slides, and is very, very easy to be used. You just need to input your utility. You have to your value. You have to specify if it is a utility or disutility, and you have to specify if an increase of the outcome is desirable or undesirable. Once done this, the software automatically calculated for you the three utility value from using the six threshold, so the 3 threshold on one side and 3 to the other side approach. The next, please. Okay, so I leave the floor to Francesco that will explain to you in how we have implemented all that I described up to now. Thank you.
Thank you, Silvia, and thanks everybody for sharing with us this webinar. So as Silvia was mentioning, I will present you some practical applications of the theory that we heard so far. in this systematic review that was published a few days ago on a new treatment, disease-modifying treatment for people with mild cognitive impairment or mild dementia due to Alzheimer's disease. These are monoclonal antibodies directed against the amyloid beta protein. Just a couple of notes before I show you the rest of the slides. In our review, we applied the threshold approach specifically to assess imprecision among the grade domains that need to be assessed for assessing certainty. But for like a explanatory purpose, we will show you examples of how, based on the real data of our review, this approach, the threshold approach, could be applied to the other domains, graded domains for certainty. So the next one. Okay. In our review, we identified the three critical desirable outcomes: cognitive function, dementia severity, and functionality that are related to the condition of interest, Alzheimer's disease. And each one of them is measured by means of a specific scale. So these are all continuous outcomes. And therefore, we, especially because some of these scales were, the estimates were expressed in different studies by means of different versions of the scales with different score ranges. So we adopted the standardized mean difference as a metric to express the estimates of efficacy. And as Silvia was mentioning, we expressed the thresholds between different magnitudes of effects by means of the Cohen's d values, 0.2, 0.5, and 0.8. And in the summary of findings table of this review, we reported the estimates of the studies at 18 months follow-up, for the simple reason that most of the studies reported results at this time point. So the next one. So this is just a figure to show you. It's not a real forest plot, and apologies for it's been done manually. So although the figures I will show you are based on the real data, the real estimates, they might not be perfectly proportional, but this is just to graphically give you an example of the theoretical concept. So when you work within this approach, you will place point estimates and confidence intervals on kind of a framework like this. As Silvia was mentioning, you see the central magnitude area, trivial no effect, as goes, on both sides of the null effect line. And as you can tell, the thresholds, the decisional thresholds between the different magnitudes, small, moderate, and large, trivial, small, moderate, and large, are the Cohen's d values. That might be negative, as you see here in the left part of the figure. Whenever the scale that you are using is expressing, a lower, where lower score is expressing a larger benefit. So the lower score, the better. So the next one. We also had a set of critical undesirable outcomes that were all dichotomous because they were expressed in all studies as number of people with the event. ARIA, it's an acronym that is indicating this new and drug-specific adverse events, stands for amyloid-related imaging abnormalities, because these are abnormalities in the brain that can be seen in the MRI. And they could be ARIA-E, where E stands for edema, brain swelling, or ARIA-H, where H stands for microhemorrhages. We also extracted data in our review distinguishing symptomatic ARIA-ENH from non-symptomatic, because symptomatic ones may be more dreadful and important, valuable for patients. Symptomatic brain macro hemorrhages, severe adverse events, and deaths were the other dichotomous outcomes. Next. So how did we define decisional thresholds for dichotomous outcomes? Here, as Silvia was mentioning, the process is a little bit more elaborated. In this, of course, if you deal with the common outcomes, you may find in the literature decisional thresholds for outcomes that have been already studied in terms of utilities. And a practical tip for this is that the utility theory is mutuated from economists, from studies of health economy, like cost effectiveness studies. The effectiveness component of a cost effectiveness study is using often utility values. In this case, we knew that in literature, there are no data about this ARIA type of adverse events because it's new. It's a drug-specific undesirable events. So we developed some utility. We defined some utility values from by eliciting them from a group of interest holders, and to which we offered a series of health outcome descriptors. So for each outcome, in other words, for each outcome that I mentioned before, we developed a structured description of the health state. They're also called marker states, and also this is like a metric, a tool used in health economics. And our interest holders were 4 clinicians with experience in dementia and 3 caregivers of people with dementia. We looked for gender balance also by involving 2 female clinicians and 2 female caregivers. And to each one of them, we asked for each outcome, after reading their descriptions, to define a utility value between 0 to 1, where 0, as Silvia was saying, means death, and 1 means full health. Next one. This is an example of what an outcome descriptor is a structured description, background, time horizon, symptoms, testing and treatment, consequences, a description in plain language, very clear, without technical terms of what a health state is. And, below you can see a visual scale where each interest holder was asked to express their utility value for each outcome. Next. Once we had all the utility values from all the people that we involved, we calculated a mean utility value for each outcome. You see it in the table above. And we calculated a weighted mean because there were 4 clinicians and 3 caregivers. So we gave a little bit more weight to the evaluations of the caregivers. And in the second table, you can see that by using the formula with the generic coefficients that Silvia was mentioning, we derived 3 decisional thresholds in absolute risk increase terms for each of the outcomes. So, for example, for ARIA-E, less than 44 events per 1,000 individuals can be considered a trivial magnitude. Between 44 and 111, a small magnitude. Between 111 and 211, moderate, and if the events are more than 211 per 1,000 individuals, we're having a large effect. Next one. So this is how the same figure I was showing you for continuous outcomes. This is how a kind of forest plot-like figure looks for dichotomous outcomes, where, you know, in the x-axis you can see, instead of coins these that we saw before, a series of threshold values expressed in number per 1,000, so absolute risk increases or reductions. Next. Okay, I give the floor again to Silvia to show you how this approach is implemented in the evaluation of the certainty domains. Silvia.
Okay, thank you. The next slide, please. So now we have defined our thresholds, then that for the example that we are showing, and also following the approach that is suggested in the grade guide, is the one that is based mainly on the 6 thresholds approach. However, for the third domain, which is study limitation, risk of bias, the suggested approach is to group the studies in low risk of bias studies, low and unclear or some concern risk of bias studies on one side, and high risk of bias studies on the other side. This would imply that you will compute a sort of an overall judgment of risk of bias. So this is not a problem if you are using ROB2. If you are using ROB1, you should decide which are the more relevant domains and elaborate and report on a concept of the overall risk of bias that derive from your evaluation using ROB1. So you should show in the report in your first plot the group of the study with low risk of bias and the one with high risk of bias, and see whether they fall in different information categories, that is, different category of magnitude of the intervention. In the example reported on the top of this figure, you see that the low risk of bias studies fall in the small benefit magnitude of the effect category, while the high risk of bias fall in the moderate benefit information category or magnitude of the effect category block. So in that case, you should downgrade one level because the two groups of studies are divided by one decision threshold. We can imagine that if, for example, the high risk of bias studies would have been fallen in the large benefit information category, you should have downgraded two levels because there are two decision thresholds that separate high risk of bias from low risk of bias studies. In the example below, shown below in the figure, on the contrary, you don't have to downgrade because both the two group of study, they both fall in the information category of trivial or no effect. So in this case, you can conclude that the risk of bias, also if present, does not influence the evaluation of the overall effect, and so it does not deserve downgrading for this for this domain. The next, please. Okay, this is an example from our systematic review. Please, Francesco, go ahead.
Thank you, Silvia. So this is an example on a continuous outcome. Dementia severity, we have this CDR-SB scale, and this outcome was extracted from 9 RCTs. So now, if we think about high risk of bias versus low risk of bias, you see that only one study that is marked in red is the only one out of, we included 17 studies in the review, and only one is at high risk of bias. And you can see that the point estimate of this study is completely outlying the other point estimates, and also the confidence intervals are extremely wide. This is why, this is because this study was terminated early for futility, And this outcome was available only on less than 20 patients out of about 1,000 that were recruited in the study. So this is why this value is shows, by the way, like a very bad effect of treatment on dementia severity. It looks like people in the treatment go much worse. But the other study that is outlying on the other side is similarly, although being not at high risk of bias, shows a point estimate that's close to large effect. But again, it is a trial that was terminated early, and here too, this outcome was available only for very few patients out of many hundreds that were recruited. So for this reason, we decided not to downgrade for risk of bias, because it didn't look like the estimates provided based on the risk of bias of the included studies was different. Over to you.
Yes. So the next domain is inconsistency. For this domain, you have to follow a three-step approach. So the first step is to give a visual inspection of the first plot showing the results of the individual studies, and see whether the point estimate of the studies are very similar or are very different between each other. And most importantly, if the confidence interval do or do not overlap. This is the same as the old approach, exactly the same. So the first doubt and the first that could raise the question is whether there is an issue about inconsistency is to look at the overlapping of confidence intervals. If they do not overlap, if they are overall all the studies fall in the same information category with a big overlapping of confidence interval, you can stop here. Also, the software automatically perform for you the statistical analysis and measure the I-square and the Cochrane p-value. And also these two aspect information provide an initial assessment of preliminary indication of inconsistency. Again, if you have an I-square of 0 or very low value, there is not a cutoff predefined. You have to decide which is relevant, which is the I-square relevant. But in any case, if it's low, less than 30%, for example, you can decide that there is no issue about inconsistency and no going further. While if the I-square is higher and the overlapping of confidence interval are poor, you have to go further and not just downgrade for inconsistency, but to make further evaluation. The next, please. You have to report the results of your individual studies in the first plot with the decision threshold to show it, and to see whether, as done before, the point estimate of this individual study with their confidence interval fall within the same information category or in different information categories. For example, on the left, you can see that you have 4 studies. The I-square is 99%, so very high. The overlapping of confidence interval is almost 0. And the studies, we have 2 studies that fall in the category of magnitude of the effect of small benefit, and 2 studies that fall in the category of magnitude of effect of trivial or no effect. So in this case, you should downgrade for inconsistency for 1 level because they are separated, the studies, by 1 decision threshold. And you should downgrade 2 levels if the studies are separated by more than that, by 2 decision threshold, 3 levels if they are separated by 3 decision threshold. On the other side, in the left, in the figure showed on the right part of the slide, there are the same 4 studies. The I-square is still 99%, but all the 4 studies, despite the fact that the 90% confidence interval are nearly no, there is no overlapping. Nevertheless, the point estimate of these studies and the confidence interval overall fall within the information category of trivial or no effect. So there is no reason to downgrade in this case for inconsistency. The next. Okay, again to Francesco for the example with our review.
Yeah, in our review, this is an example of another continuous outcomes relative to cognitive function, again measured with a continuous scale. Of the 14 studies included, most of them have a point estimate that falls within the trivial no effect magnitude, and apart from a couple of outliers with very large confidence intervals that are widely overlapping with all the rest. So, the visual analysis suggested not to downgrade for inconsistency, but also the statistical heterogeneity with the I-square of 10 and absent, like a p-value that is not statistically significant, suggested to not to downgrade for inconsistency. Silvia.
Yes. Okay, and now indirectness. Though the indirect is rarely an issue within the context of systematic review, though it could happen in some cases. But this is a problem that there are more frequent if you are doing clinical guideline. However, if you want to assess whether there is indirectness, or you suspect that there is indirectness issue, you have first to identify the source of indirectness. So that is if due to the characteristic of participants, of intervention, or comparator, or setting, and you should group the studies in two groups. One called direct evidence, so without issue about indirectness, and one of indirect evidence. And then also you have also to report your two summary estimates in your first plot with the decision threshold, and to see whether the direct and the indirect evidence fall in different category of magnitude of the effect. If yes, you should downgrade for indirectness. If not, you should not downgrade for indirectness, as is shown in the lower part of this field in this figure, in the example shown in the last part. If a situation happened that the one that is shown in the lower part, in the bottom of the figure, you can conclude that also if there are if participants are different for some reason, or the doses of the way of delivering the intervention is different for some reason, this does not have any impact on the effect of the intervention, so there is no need to downgrade for indirectness. The next. And then we have imprecision of the overall estimate. This is the last point. We are not going to discuss the item, the domain dissemination bias or publication bias, because this for this domain the criteria are not changed. You can downgrade just for one level, and then the approach is not changed, is not still changed. So there is nothing new to do about this. So now I describe the imprecision, and then I leave the floor to Francesco for the example again. So for imprecision, you have to look at the overall estimates of your meta-analysis, and you have to see, this is maybe the most the simplest of the approach to, considering the different domains, because you have just to see how many decision thresholds are crossed by the confidence interval of the overall estimate. If the overall estimate cross one threshold, you downgrade one level. If it crossed two thresholds, you downgrade two levels. If it crossed three or more thresholds, you downgrade three levels. Again, as I told before, the crossing the line of no effect does not indicate a lack of effect. It is not a reason for downgrading. And this is it's a big difference compared to the old approach. The next, please. This is an example, 4 different examples. In the example number 1, you have an overestimate that fall in the category of magnitude of the effect of trivial no effect, and the confidence interval are within the 2 threshold that distinguishes between trivial effect and small benefit or small harm. Though one confidence interval cross the line of no effect, this is no more considered as a source as a reason for downgrading. In the example number 2, you have still overall estimate that fall in the category of a magnitude of the intervention of trivial or no effect, but you have one side of the confidence interval that cross the decision threshold between trivial effect and small benefit, so you should downgrade one level. In the example number 3, you have the overall estimate that fall in the magnitude of the intervention of small harm, but the confidence intervals cross 2 thresholds, one between small harm and trivial no effect, and one between small harm and moderate harm. So you need to downgrade 2 levels. And finally, in the example number 4, you have the overall estimate that fall in the magnitude of the intervention category of small benefit, but the confidence interval cross 3 thresholds, one between trivial effect and small benefit, one between small benefit and moderate benefit, and one between moderate benefit and large benefit. So here we have to downgrade 3 levels. The next, I think that, okay, I leave the floor to Francesco again.
Yes, thank you. I will show you 2 examples of imprecision assessment, one on one of our continuous outcomes of efficacy, which is, again, dementia severity, the clinical dementia rating sum of boxes scale. Next one. Okay, the pooled overall estimate in terms of standardized mean difference is minus 0.12. I remind you again that this is a scale where the lower score, the better. So this is why it's a negative value. And the confidence intervals basically crossed, the higher confidence interval crossed the threshold between trivial and small. So click again, Claudia, and the animation shows that no. We downgraded 1 level for imprecision, based on the principle that Silvia was mentioning before. 1 point I would like to make, one last point about continuous outcomes. This is, now the reason for which we use the standardized mean difference is clear, in order to use the Cohen's d values as thresholds. But in our summary of finding table, we reported also a back transformation of the SMD into mean difference, because this was a suggestion by the peer reviewers of our review. It is useful for readers to know, what is the mean difference in terms of actual points of that scale. This is, again, useful for clinical contextualization, especially when you do have a minimal clinically important difference. For example, for this scale, there are many papers defining it as 1 point, at least 1 point, to have a clinical meaningfulness. The MD of this scale was slightly higher, but it was way below the MCID for this scale. So again, this might be useful. When you have an MCID, it's useful, at least in the summary of findings table, to report it. Next one. This is an example on a dichotomous outcome, ARIA E. Next. Okay, here you see that the thresholds, as I said before, are expressed in terms, in absolute terms. And so, in the case before, before in the previous slide, we took as a reference the Cohen's d values. Here we took as a reference the absolute risk values that from the table, from the elicited utility values table that I was showing before. And for this outcome, the absolute risk increase point estimate was falling into the small magnitude, but the higher limit of the confidence interval went into moderate. So we downgraded here too for imprecision, also this estimate. Okay. Silvia.
And this is just a last consideration about the overall judgment. So using this approach, if you when you perform the meta-analysis, you usually use the random effect model because you expect there is some grade of across study variation, but the random effect model incorporate also and account when the in the building of confidence interval also the across study variation, which is one that you can see when you consider inconsistency. So the problem is that in here, when you assess the certainty of the certainty of the evidence and domain imprecision, you are looking at how wide are the confidence interval on the overall estimate. But if there are inconsistency, it's very likely that the inconsistency will translate in a wider confidence intervals. And the same is true for risk of bias, for example. As I've shown you before, if there are studies with high and low risk of bias or with direct and indirect evidence that fall into different information category, these differences will very likely also influence the wideness of the confidence interval of the overall estimates. This is just to say that all these domains are interrelated, so you have to avoid to, you have not to reason consider one a domain at a time without remembering or looking on what we are doing with the following on the previous domain, but you have to look at the overall evaluation in order to avoid to penalize the evidence twice or three times for the same underlying issue. So for example, if you have already downgraded for inconsistency, maybe you should not downgrade for imprecision. If you have also downgrading for the risk of bias and you see that inconsistency is due to risk of bias, you should not downgrade again for inconsistency. Okay? And now the conclusion, Francesco?
Yeah, very quickly. I'm sorry, we are over time. Okay, so the opportunities by this method is to move ahead from the old approach, expressing estimates by simply referring to a non-null effect. Both continuous and dichotomous outcome can and should be assessed with decisional threshold, defining different magnitudes of effect. And, especially defining, explicitly a judgment about the decisional threshold allows a more structured assessment of the great certainty domains. Next is about, what is left. There is a lot of work left on a methodological point of view because, especially for systematic reviewers, if you elicit utility values, we should be sure that these come from a representative sample of the population of interest. Patients' representatives in particular should be engaged in a consistent way, and health outcome descriptors should be developed consistently. And also, going to the last point that Silvia was making, we need a better definition and elaboration on how to manage the possible overlapping between domains, especially imprecision and inconsistency, but also others, to avoid over downgrading in terms of certainty.